Are you ready to take a journey through the vast and mysterious space between the stars? Join us on an epic adventure into the depths of the interstellar medium, where we'll explore the complex and fascinating web of gases, dust, and cosmic rays that fills the vast emptiness of space. With stunning visuals and cutting-edge research, this video will take you on a journey like no other, as we uncover the secrets of the universe's most enigmatic and elusive substance. So buckle up and get ready to blast off into the unknown. What is the interstellar medium? The interstellar medium, ISM, is the material filling the space between the stars. It consists mainly of gas, 99%, and dust, 1%, mostly found in the form of clouds, or nebula, plural of the nebula. About 75% of the interstellar gas is in the form of hydrogen, and nearly the remaining 25% is helium. This gas is extremely cold, around 10 K, and diluted, about 1 atom per cubic centimeter. For comparison, the air we breathe has a density of about 30 quintillion molecules per cubic centimeter. However, despite this very low density, the amount of matter adds up over the vast distances between two stars. Interstellar dust is not like the dust you might find under your bed. It consists mainly of silicates, iron, carbon, and dirty ice. Dust particles are irregularly shaped and very small, just a fraction of a micron across, similar to the wavelength of blue light, and have typical temperatures of around 100 K. What is in between the stars? The space between the stars is not empty but mostly filled with dust and gas that we call the interstellar medium, ISM. When starlight travels through a dust cloud, some of the light is scattered, and thus the star will appear a little dimmer than without the dust, an effect known as extinction. For light at different wavelengths measured, so for the different observed colors, the effect varies. Light at shorter wavelengths, towards the blue end of the spectrum, is scattered more strongly than those at longer wavelengths, red end of the spectrum. This characteristic wavelength dependence allows astronomers to reconstruct the amount of the extinction starlight has undergone, which relates to how much dust and gas happens to be between us and that star. ISM creates stars. The ISM creates stars, and the stars give back to the ISM. This is a place of cosmic recycling on a galactic scale. The cycle starts in cold, dark clouds. Tens of light years across, these clouds house enormous quantities of molecular hydrogen. All it takes is a nudge from outside. A passing star cluster, a nearby supernova, the sweep of a galactic spiral arm, and the cloud becomes unstable. Pockets of ever-increasing density flourish, driven by the cloud's gravity. From these dark cocoons, stars are born. Upon ignition, they blow away the remaining material and light up the cloud. The Orion Nebula, the Lagoon Nebula, and the Witch Head Nebula are all clouds of gas and dust lit up by nearby young stars. At the other extreme is the ionized gas. Shocks from powerful supernova explosions heat some of the gas to millions of degrees. There is enough energy to rip electrons from their atoms. The gas responds by glowing with X-ray radiation. Some of this gas is even blown free of the galaxy into intergalactic space. Between supernova shocks, young stellar winds, galactic magnetic fields, and turbulent motion, the ISM has a rich and complex structure. Filaments of gas, dense pockets of hydrogen, and expanding voids connect the network of material threading the galaxy. Most of this web is invisible. To map the ISM, astronomers must turn to other parts of the electromagnetic spectrum. The cold, dark gas emits radio waves. Warm dust shows up in infrared telescopes. The superheated plasmas glow with X-rays. By putting together observations at all these wavelengths, we can draw a picture of what the interstellar medium around the Sun looks like. Interstellar cloud. We are currently drifting near the edge of a cloud of gas 60 light-years across the local interstellar cloud. The cloud itself is being blown away by a nearby grouping of young stars. the Scorpius-Centaurus Association. About 400 light-years away, it is the closest region of massive star formation to Earth. Supernovae in the association have evacuated the space around the young stars to form a bubble in the ISM. Adjacent to this void, our Sun and the local clouds sit in another bubble, the local bubble. Our local bubble has extremely low densities, only about 1 particle for every 10 cubic centimeters, about 300 light-years across. The local bubble is also the result of a supernova explosion near Earth sometime in the last 10 to 20 million years. The ISM reminds us that the galaxy is far more complex than appears at first glance. Without advances in technology, much of the universe would remain invisible to us. But even our humble eyes can catch glimpses of the hidden universe. On a night when you can see the band of the Milky Way arching overhead, look closely. There are pockets where the light is missing. You are seeing the dark clouds of the ISM, blocking the light from more distant stars. These are the sites of star formation and future stellar nurseries. And you don't need a telescope to see them, just a dark sky and a willingness to look up. Can we make it to the space between the stars, as in interstellar space? Since warp drive is still just a fantasy, getting to interstellar space takes a long time at present. Voyager 1, the first spacecraft to make it, was about 122 astronomical units. Earth is 1 astronomical unit, or AU, from the Sun. That's about 11 billion miles, 18 billion kilometers, from the Sun when it exited the heliosphere and entered interstellar space. The spacecraft launched from Florida in 1977 and entered interstellar space in 2012. That's a 35-year trip. Of course, Voyager 1 didn't make a beeline for interstellar space. It took the scenic route and toured Jupiter and Saturn first. Voyager 2, traveling slower than Voyager 1, also toured Uranus and Neptune, and took 41 years to reach interstellar space. In conclusion, the study of the interstellar medium is an incredibly important and fascinating field of astrophysics that has the power to unlock some of the universe's biggest mysteries. By studying the stuff between the stars, we gain valuable insights into the processes that drive star formation and the evolution of galaxies. The latest advancements in observational techniques and theoretical models have allowed us to make great strides in understanding this complex and ever-changing medium, but there is still so much more to learn. If you are keen to learn more about space, don't forget to subscribe to our